Hi class. Okay, I wanted to do a couple examples for you guys based on what we did today in class. So this first one's going to be finding the projection. Okay, that's how we ended class with that formula. So in this one, and it's like numbers 29, 30, 31, 32, 33 in the homework. Okay, so the first thing, let's get our formula that we came up with in class. So the projection is it's going to be u dot v over the length of u, the length of v squared times v. Okay. And so what I think can be helpful is to have a little picture here. So I'm going to draw, let's see, so negative 2, 9 and negative 1, 2. So we've got a negative 2, 9 vector is going to be left 2 and up 9. So it's going to kind of something like that. And then v is negative 1, 2. Negative 1, 2 is a much shorter one, like that. So we've got u here, and v. And I want to find the projection of u onto v. So what I'm doing is I'm looking for that component of the vector u. So here's my vector u. I want to find its component in the direction of v. So it's kind of like that new horizontal component. So I'm looking for this piece here. So what I think can be helpful is to let's extend this out. So if we were to extend v out, it kind of looks like this. Okay, that's v all the way extended out. So I'm looking for that amount of u in the direction of v, which we had called ux, u sub x. Alright, so that's what I'm going to be calculating. So I just need to plug into my formula here. So this u sub x, which is the projection of u, the projection of u onto v, is going to be u dot v. Alright, so let's do that on the top. We got negative 2 times negative 1 plus 9 times 2 over, so then I need the length of length of v squared. So that's going to be the square root of, and then length of v would be negative 1 squared plus 2 squared, and then times v. So that's going to be times the vector negative 1 comma 2. So let's do some math here. On the top, I'm going to get 2 plus 18. That looks like 20 on the top. And on the bottom, I'm going to get 1 plus 4. So square root of 5 squared is just 5 times my vector negative 1, 2. Well, that's 4. 20 over 5 is 4. So that's really 4. So now I'm just multiplying 4 by negative 1, 2. So I'm going to get my final answer is the vector negative 4, comma 8. Which is my answer. So it's equal to, we could call it our u sub x, or the projection of u onto v. So that vector there, negative 4 comma 8, so negative 4, 8. Now I know my picture is not really to scale very well, but if I did a vector negative 4, 8, it would be this one here, this u sub v, this u sub x, the component of my u vector u that's parallel to the vector v. Okay, and so that is my answer there. So now the second part says write u as u equals u sub x plus u sub y. So as the sum of its components. Well, what it means, what happened here is we haven't calculated the y component yet. So what we have, I know my u vector, we were given that at the beginning, negative 2, 9, is going to be equal to, and I already calculated my x vector. My u sub x is negative 4 comma 8, plus some other vector, which we can call as ab, you can call it xy, I'll call it ab. Okay, my u sub y, which is going to have some a and b value. Well, this is just a simple equation where I'm going to subtract this vector to the other side so I can solve for my vector AB. So if I do -2 minus -4, that's +2, and 9 minus 8 would be 1. So that's my A comma B, which is U sub y. That, if we go back up to my picture, that's going to be that vertical, the new vertical component. Alright, so let's draw that up on here. That's this piece here, which is U sub y. Okay. And so what this part is trying to show you guys is that we can, once we find my new horizontal component, the U sub x, it's really easy to find the U sub y using this formula because we know U is made up of U sub x plus U sub y. U sub x plus U sub y. Okay, so we would just plug this back in here, and that would be writing U as the sum of its two components, U sub x plus U sub y. Alright, so there's that problem. The next problem has to do with a car on a driveway. So I'm going to work through one of the examples in the book. This is similar to number 49 in your homework here. Okay, so we've got this car sitting on a driveway. It weighs 3,000 pounds. It's a 15-degree driveway. So now what we're going to have is gravity working in a downward direction on this car, right? So gravity is going to pull this car straight down into the driveway. We know that that's happening at a magnitude of 3,000 pounds, okay? And so what we can do is we can break that force down into its two components. So that there's one component of this gravity that is bringing pushing the car down the driveway. So that's this piece here, right? And then there's another component of it, right, that is pushing it straight into the driveway. Okay, so perpendicular to the driveway. That's the other component of it. All right. Now, in this problem, it's not like the projection problem where we're projecting onto a vector of a particular length. All right. So all I need to do is a little bit of geometry here to kind of figure out the angles in this triangle. Okay. Now I want to point out a couple triangles that we've got here. So if you look at this triangle here formed by the ramp, my gravity vector, and horizontal ground. So there's one triangle. And then the other triangle is formed by, again, that gravity vector, right? The perpendicular to the ramp vector and the parallel to the ramp vector. Okay, so those two triangles, we're going to show that they're similar. So this angle here is the same in both of them. So they have one angle that's the same. And each of these triangles has a right angle. There's a right angle, and there's a right angle. Okay, so since they both have two pairs of congruent angles, we know that all three angles are congruent. So I can figure out that this angle is 15 degrees. All right, and that allows us to do what we're going to do next. So now that we know that that angle there is 15 degrees, I can use a little bit of trigonometry to just figure out the length of this piece here. Okay, the length of my component in the direction of the ramp. Okay, so now let me zoom back out. Okay, sort of fixed it, but I lost that second question, so oh well. So right now we can kind of do our calculations here. Find the force required to keep the car from rolling down the driveway. So if we look at our right triangle there, we want to find this horizontal, the new horizontal piece that is parallel to the ramp. Okay, so I've seen my 15-degree angle there, so I could use sine, all right, because that's opposite, and I know the hypotenuse is 3,000. So we'll just write a nice little sine of 15 degrees is going to equal my force, okay, we'll call that force x, like our use of x, over 3,000. All right, and this should be our magnitude, right? Because we're dealing with the magnitude of the force. So my magnitude of the force in the direction of the ramp is going to be 3,000 sine 15, which will be about 776. And my units are pounds. Okay, so that would be the force required to keep this from rolling down the driveway. All right, if we wanted to figure out, so then the next question that's missing from the bottom now, part B, is find basically the force pushing into the driveway. That would just be going the other direction with cosine. So we would say cosine of 15. All right, that's going to give me that adjacent side right there. All right, so we'll call that force y. It's going to be the length of f sub y over 3,000. Okay, so if we solve that, we'll get our force in the direction perpendicular to the ramp is going to be about 2,898 pounds. Okay, we'll spend a little more time with some of these the next few days. Thanks.